So this afternoon, good afternoon everybody, by the way. This afternoon we're having a look at robots on Mars. I'll be saying a little bit about Mars and Martians. I'll be introducing how many landers and rovers the Americans, not everybody, but the Americans have landed, asking what have they found and what's next. In other words, what's the next robot on Mars likely to be? So we humans have had a fascination with Mars for quite a long time. Some of you, well, most of this audience, too young to remember War of the Worlds. Either the book, or the radio broadcast, or the films, or maybe even the musical from quite some years ago. But I guess for you guys, if you were to say Martian, you don't necessarily think of War of the Worlds, you think probably more likely Matt Damon and the more recent film. But we should perhaps just take a second and think how amazing it is that we've done this. 100,000 years ago, some humans were still living in caves. And yet it's now possible for us to build machines, put them on top of rockets, send them to another planet, have them land, and have them send back images like this. Of course, we're interested, is there any life there? It looks like a rather dry, arid planet. But there are definitely signs that water has flowed on Mars. There have been lakes on Mars. If water was there, just like on the early Earth, the conditions were right, probably, for life to evolve. If we've got water, we've got an energy source, and we've got all the right minerals and compounds, life could find a way. We haven't found any life on the surface, but there's very likely to be water below the surface. So maybe we have to drill down to find the water, and perhaps there we will find the life. But let's not forget just what an amazing achievement it is simply to be able to get robots there and have them send back images and videos like the one we've just seen. So I'm not going to turn this into a history lesson of everything that's been sent to Mars. I've simply picked out a few missions from NASA because it's easier to get the information from NASA than anywhere else. There have been Chinese landers and rovers, but I'm just talking about NASA missions. The first one I remember was in the 1970s, the Viking mission. Since then, there have been others. For instance, a lander and rover pair sent in the latter part of the last century. And since then, there have been a number of other rovers. The relatively small rovers called Spirit and Opportunity, sent as a pair, landing in different parts of Mars. Opportunity, otherwise known as Oppie to his friends. There have been other landers and rovers. Phoenix, Curiosity was a much bigger rover sent in the middle of the last decade or so. InSight was a lander that looked at Martian geology and discovered that Mars has earthquakes, or perhaps we should call them Marsquakes. Even though there's no tectonic activity, there's still some vibration of the surface. And the most recent rover that is still working well is Perseverance, or Percy to his friends. Now, I'm not going to go through all of these. I'm simply going to highlight the ones in red, and I'm going to say a few words about those. Viking, the two small rovers, Spirit and Opportunity, and the latest one that's roving, Perseverance. So, starting with Viking, this, of course, is absolutely ancient history to you guys, but for me, this is one of my first memories of what happened back in the 70s, was this thing landing and sending back color images from the red planet. So no, we didn't send Carl Sagan to Mars. He's just standing here next to a model on Earth, just to give you an idea of scale. So even back then in the 1970s, we were sending landers about the size of a car, weighing a little less than a ton, onto the surface of Mars. And I actually still remember the day I first saw the television transmissions of the color images from the red planet. I was, of course, a person of a certain age who remembers the moon landings and black and white images of astronauts bouncing around on the moon, but this made almost as much impact, seeing the first color images from the surface of Mars. We can ask, how do we get there? Well, we need a rocket, of course. You're doing the calculations for that. A relatively small rocket to get you to Mars compared to the huge rocket that was used to get to the moon. Mars is, of course, much further away than the moon, so why did it take a 3,000-ton rocket to get astronauts to the moon, whereas it only takes a relatively small rocket to get to Mars, which is much further away? As I'm sure you're now calculating, it's not the distance that matters. In the case of a Saturn V, it had to be that big because it had to lift more than 100 tons off the surface of the Earth in order to get the Apollo spacecraft, the third stage, the Apollo command module, lunar module, etc., on their way to the moon. So it's all about mass, and I'm sure you're starting to appreciate that it's all about mass, how much mass you want to get from A to B. That dictates what side of rocket engines you need to change your velocity for a given mass. Let's think about, assuming you've used a Hohmann transfer to get your spaceship to Mars, what do you do when you get there? For Spirit and Opportunity, the first thing they did was aerobrake through the Martian atmosphere. It's only a very thin atmosphere, but when you're traveling at speed, it's a good way of bleeding off a lot of excess speed. Once it was traveling slowly enough, it deployed a parachute. At this point, it is still supersonic. And so it needs to be a very big parachute to catch the very thin atmosphere on Mars. Then the heat shield was removed, and the rover itself is in the middle of that little pyramid on the end of a tether. Question, how do you get this rover down onto the surface? It may only weigh a few 100 kilograms, but you still have to drop it. So how do you do that? Airbags. That's the easiest, cheapest way to get a small mass onto the surface. You don't need a precise landing. You just need to get close. It doesn't matter if you're drifting sideways. You get close, you let it bounce, and bounce, and bounce. It's fine for a small rover the size of a coffee table. I don't suggest you build this into your plans for humans, okay? The G-forces would be quite substantial. Of course, you have to make sure the rover can withstand this amount of acceleration. It actually bounced 28 times before it finally came to rest. Once its accelerometers told it had come to rest, you can deflate the airbags. You now have a rover sitting in that little pyramid. The pyramid unpacks itself and self-rights. And the first thing the rover has to do, you can see the rover sitting in the middle of the pyramid there. The rover has to do a little bit of self-diagnostics, and one of the first things it does is unfold its solar panels. These early landers and early rovers were solar powered. And we need sunshine to charge the batteries to keep all of the rover systems operating, not simply the cameras and any scientific equipment on board, but also, a point I'll come back to in a moment, the heaters to keep the rover warm. So there goes the camera on a mast, and just behind that, something that looks like a table tennis bat. That's a phased array antenna that allows the rover to talk to whatever ship is in orbit and then ultimately send information back to Earth. So the rover makes sure it is the right way up, tells Mission Control, I've landed, what do I do now? And then Mission Control instruct it to actually move off its platform. So the first thing it has to do is unpack its wheels that have been tucked away underneath to fit into the pyramid. It unpacks its wheels, puts itself back on a level, and before it moves onto the Martian surface, it then needs to check where all the rocks are. So its stereo camera looks around, and in particular looks ahead of it, and figures out what is it going to do now. Which way is it going to go around that rock to make sure it misses it? If something is in its way, it will stop, turn its wheels, do a little bit of a rotation, there it goes, and then move off. The plan was that Spirit and Opportunity rovers would last for, well, their design lifetime was 3 months, according to NASA. In fact, they lasted much longer than that. Spirit had a problem after a few years. Opportunity lasted for an incredible 14 years, despite the fact that its design life was only 3 months. What is it that ultimately stops rovers roving? Well, in the case of Spirit, it had a little bit of an accident and it damaged one of its wheels. But in the case of Opportunity, what got it in the end was power. The solar panels have to keep the batteries charged for it to stay alive. If we think about what's going on, let's have a look at the solar panels. This is a selfie taken from a camera on a mast looking directly down. We can clearly see the solar panels of this sort of butterfly shape of the solar panels of Opportunity. This is what it looked like shortly after it arrived, relatively clean solar panels picking up plenty of sunlight. But after a little while, after basically not much more than months, the solar panels got covered in Martian dirt. And that's another selfie taken later, and you can hardly make out the solar panels because they're covered in Martian dust, which is of course the same color as the background of the rover itself. So of course, if your solar panels are getting covered, you're going to be losing power, and it's going to be very difficult to power all of your scientific equipment or your heaters to keep you warm. You might say, that's crazy. You can't send a rover to Mars and not think about the solar panels getting dusty. Why didn't they just have a dustpan and brush and just brush the Martian dust off? Well, it's a bit like volcanic dust here on Earth. It is very scratchy. If you attempt to remove this dust by scraping it away with a brush, all you'll do is scratch the surface of the solar panels and they will lose efficiency again. It's rather difficult to envisage a situation where you pick up the rover and shake it. That doesn't really work, so they just put up with the fact that the solar panels get dusty. Luckily, every once in a while, a dust devil comes along. The Martian atmosphere is very thin, but it does have a little bit of wind now and again, and occasionally you get these little dust devils, or mini tornadoes, and they can clear the solar panels and the efficiency goes back up again. But ultimately, that's what got to Opportunity. Because if we think about a comparison of Mars and Earth, the tilt of Mars and the tilt of Earth relative to the plane of the solar system, very similar. And the length of time it takes to do one rotation, again, very similar. 1 day in the case of the Earth, 24.5 hours in the case of Mars. So the day-night cycle and the seasonal cycles of Mars are rather similar to Earth. But one key difference is Mars doesn't have a thick atmosphere to keep it warm at night. The night-day temperatures on Earth aren't so different because if it warms up during the day, the atmosphere acts as an insulation blanket and keeps us warm at night. But on Mars, you don't have that. You might have a daytime temperature which is above freezing, if you're lucky, but the night temperatures on Mars can plummet to minus 100 Celsius. If you don't keep the rovers warm at night from battery power, from being charged with solar power during the day, then the rover's temperature will drop to something like that temperature, and they cannot withstand that. The rovers have to be kept somewhere close to freezing point, or preferably a little bit above the freezing point. If they drop to minus 100 Celsius or less, then their electronics will effectively die, and there's no way of reviving the rover. So it is the solar panels feeding the batteries, feeding the heaters that will often dictate how long a robot can last on Mars. In the case of Opportunity, it was unlucky enough after 14 years on the surface, so no one can complain it didn't do a good job, but 14 years after it landed, it went into a Martian winter and there was a dust storm on a particular day. A lot of dust was kicked up. Basically, the solar panels, although they were still operating, they could not see the sun. The sun was obscured by a global dust storm across Mars. And so, if it couldn't see the sun during the day, it couldn't recharge its batteries. And a Martian winter, they knew, was going to be a problem. So the last transmission from Opportunity, as it failed to recharge its batteries and it started to head in to a Martian winter's night, the last transmission from Opportunity was battery low, getting dark, and that's it. That's all we heard from Opportunity. It must have died that night. So that was Spirit and Opportunity. Some years later, NASA said, we want to send a bigger rover. Opportunity and Spirit were great, but we want to send a bigger rover with more scientific equipment, the ability to drill into the rocks, etc. So they decided on a couple of missions called Curiosity and Perseverance, very similar mission profiles, so I'll just describe Perseverance. Here they said it's going to be a much bigger rover with a much greater power demand and we want it to last for years and years and years rather than the design of 3 months for spirit and opportunity. So they went away from the idea of using solar panels, and instead they chose to use radioisotope thermoelectric generators. A radioisotope, in this case plutonium-238, a pure alpha emitter. I'll leave it to you to think, why do you want an alpha emitter, not a beta or a gamma emitter, to give you a source which you can use the heat to generate all the power you need? So let's have a look at how Perseverance worked. To start with, similar to Spirit and Opportunity, you get it to Mars on a Hohmann transfer, and then you aerobrake through the Martian atmosphere. There's Perseverance inside its shell, getting vibrated somewhat. There's a finite amount of steering possible. There are jets on the shell, so you can steer to some extent. But again, you need a supersonic parachute to slow you down to the point where you can land. But this is too heavy for airbags. So what do you do with a 1-ton rover? You drop the air shell and you drop the rover. Retro rockets slow it down, but the retro rockets can't go down onto the surface because they would kick up so much dust, your rover would be covered in dust even before you start your mission. So they decide where they want to land. The rover decides for itself. It's not controlled by mission control. It looks down with cameras, decides where it's going to land, and then when it's decided that's where I want to be, it goes into a hover above the surface. And then Perseverance is winched down on cables. When it touches the ground, the cables are cut, and the sky crane, as it's called, flies off and crashes some distance away, safely distant from the rover itself. So there's Perseverance on the Martian surface. The radioisotope thermoelectric generator is that thing that you can see at the back there of the rover. This long, slow pullback reminds us that even if you've got half a dozen landers and rovers exploring the surface of a Mars, it's still a big planet. And any rover can't rove more than a few kilometers. They don't go hundreds of kilometers. They only travel kilometers away from where they landed. And if you want to explore a planet with only a few dozen rovers, you've got to be very careful where you decide to put them, which is why for the most recent rover missions, they've decided to go to places where there is evidence that water has flowed, because they think that's the best place to start drilling in rocks and perhaps finding signs of life. So there's a selfie of Perseverance, or Percy, and sitting next to Percy there's a little helicopter. You can see Percy is just checking that the helicopter is still there, like a nervous parent, just making sure it hasn't run off anywhere. How do you take a selfie like this? Because it seems like the camera we're looking at in the middle there, it looks like there's the camera. Well, there's one of the sets of cameras. There's also a camera on the arm that's used to do the drilling as well. And that drilling arm is then used to take the selfie. It's not like a phone where you just hold it up, click, and you're done. This selfies taken on these rovers has to be built up because of the field of view and the nature of how the data is taken. And so the selfie is built up frame by frame by frame to get the complete image, and then the robot arm itself is extracted. There's the robot arm, and the circle there shows you the lens of the camera. So the robot arm moves backwards and forwards, up and down, always with the lens in the same place, so you can then get a mosaic that you can stitch together to get the final version of the selfie of Perseverance and its little helicopter Ingenuity, otherwise known as Ginny. Where did Ginny come from? Well, it traveled on the underbelly of Percy. So Percy had a plate on the bottom to protect it. Once it had landed, that plate was removed, and then down comes Ingenuity and plonks itself onto the surface. Percy then rolls away to leave Ingenuity exposed. Ingenuity took a number of different flights. It's there in the bottom left-hand corner in case you can't quite see it. So this is a video taken by Percy of one of Ingenuity's flights. I'm not sure it comes across in the audio, but perhaps you can see hear a little bit of wind noise and also a hum. The hum is the sound of the helicopter blades turning. So you're listening to a spacecraft on another planet. The idea of a helicopter is, well, this was really just a prototype, a relatively small device with just a camera, essentially. The idea is, in future missions, you might want to use a helicopter because it can scout a long way ahead. Remember, rovers don't travel very fast on the surface, but a helicopter can travel relatively fast, quite some distance, and scout over the top of the next hill or round the next hill and figure out where's the best way to go. What's the best way of getting from A to B? Is it this route or that route? Helicopters can be great for scouting. But also as a prototype, simply to show it is possible to fly on another planet. NASA now have plans based on Ingenuity of, well, if we can do it on Mars, let's send helicopters to more exotic places. And there are plans to send a helicopter to Titan, the moon of Saturn. Titan has a very thick atmosphere compared to Mars, so it should be possible to build a much bigger helicopter with much more scientific equipment, not simply a camera, but any amount of scientific equipment we want to think about, simply because the thicker atmosphere means you can produce a higher thrust and hence you can support a much greater mass. Whenever NASA sends any missions, whether it be to Mars or perhaps in the future to the moons of Saturn, and in the past, it's always tried to keep the public on board. And one option is to get yourself a boarding pass. If you're interested, a few years back, I asked for a boarding pass for the Mars 2020 mission. This is the one that produced Perseverance as the main rover, Perseverance and Ingenuity. They're free. You just ask NASA for a boarding pass, you get one, and then these boarding passes are stored, in this case, on a little plaque on one of the metal ribs, and that white metal rib is sitting at the back of Perseverance. So in other words, you can ask NASA nicely, and I'm sure they won't say no, and your name can be sent to various places in the solar system. So I know that when Perseverance is roaming across Mars, making all sorts of discoveries, who knows, maybe even life, well, I'm going with it, because I know that my name is there. It costs NASA essentially nothing, an extra milligram to store a few million boarding passes probably. If you're interested, if you go to the NASA web pages, you can find what the next mission is. I know that they are giving out boarding passes for the Artemis program. They could well be giving out boarding passes for other missions to the outer solar system. They cost nothing, make good Christmas presents. So what are we doing on Mars? Why are we exploring Mars? Why do we have the rovers there? Well, because we're always curious about what's going on with our neighbors. We want to study the Martian geology. We want to study the Martian climate. And it's not necessarily the be-all and end-all, but we are always interested in, is there life out there? That's why we're also going to the icy moons of Jupiter, for instance, to ask the question, is there life there? It may well be that there's no life there now, but we still want to answer the question, was there ever life? And if life evolved, is it simply dormant, sitting in water below the surface of the planet? Perhaps you saw fairly recently the results of the analysis of a discovery made about a year ago, where they saw particular markings in rock, which they think is the result of microbial life. They've spent about a year trying to come up with, if it's not life producing these markings, these so-called leopard spots, if it's not life that has produced these markings, what else could it have been? They've spent a year trying to come up with alternatives, and they haven't. So they still think life is the most likely explanation for the particular pattern of spots they've seen on rocks discovered about a year ago. So it's looking more and more likely that life did exist on Mars. There have been Martians. And of course, you're quite aware that one of the reasons to explore Mars with robots is to prepare and pave the way for human exploration, which is precisely what you're doing today, this week, is trying to figure out not how we get robots to Mars, but how we get humans to Mars and hopefully get them back again safely. Along the way, Perseverance is not only drilling rocks and trying to do some experiments to try and understand what it is it's looking at, it's also taking samples. Perhaps you can't see that, a little vial, where it's taking samples of rocks, drilling into rocks and putting a little bit of dust into a sample tube. It's also taking samples of the atmosphere. And these samples, many dozens of them, some of them are being kept on board Perseverance. Some of them are being left as a breadcrumb trail as it moves around the surface of Mars. Of course, we know exactly where they've been left. It makes a note of its position, so we know there's a breadcrumb trail of samples, and some of them are on board Perseverance. What we would really like is to get these samples back to Earth. Curiosity and Perseverance are very sophisticated robots with a certain amount of scientific equipment on board, but there's a limit to how much you can put into a 1-ton rover. It would be much better to have those samples brought back to Earth where we can analyze them in state-of-the-art instruments back here in Earth-based laboratories. But if those samples are sitting either in Perseverance or on the surface, how do we get them back to Earth? NASA and ESA combined, the European Space Agency as well as the American NASA, are thinking about how that could be done. So Perseverance is collecting samples, but the plan is to send another spacecraft, a lander, not a rover, a lander. Once it's landed, Perseverance will trundle its way up to the lander, and it will take all the samples it's been collecting up to that point, and it will transfer them one by one into this lander. But as you can see from the video there, perhaps a couple of dozen or so samples. It will then be sealed up. What happens next? The entire lander doesn't take off, it's too heavy, but it's been filled with the samples into a little rocket which then fires its way off the surface of Mars. There it is, Perseverance, watching it go home. So this little rocket will then take the samples back into Martian orbit, rendezvous with another spacecraft which will then fly them back to Earth, the so-called Mars Sample Return mission. It's a joint mission between NASA and ESA. They've planned it for a little while, but they clearly launched Perseverance to collect the samples before that they've got to the point of actually having this mission decided. Turns out to be a little more expensive than they were hoping to send a lander there to pick up the samples and bring them back to Earth. So they're trying to find cheaper ways of doing it, perhaps simpler, perhaps cheaper ways so that they can get these samples. The samples will stay okay for years and years and years, but the sooner we get them back to Earth, the sooner we can analyze them with the scientific instruments we have down here. Where next? What is the next rover that's going to land on Mars? I've been telling you about NASA missions. I'm pleased to say an ESA mission is on its way. Perhaps around 2028, we could see a rover on Mars from the European Space Agency. And the European Space Agency has UK involvement. So we will see a Union Jack on Mars, hopefully in the next few years. This is called the Rosalind Franklin rover. You can see it's rather small compared to Curiosity and Perseverance. Again, its mission not particularly long, so solar panels will probably be enough. But the difference with this rover, called the Rosalind Franklin rover, is that black box that you can see on the front. That's a drill. And the idea is it's going to drill something like 2 meters down to where we think there is subsurface water. And then we'll see if there's any sign of microbes there, which will back up the idea that what we saw in the rocks earlier was signs of early life on Mars. So yes, this is a European venture, and it's being built in the UK. Hurrah! So here at Airbus UK, a whole load of people putting the Rosalind Franklin rover together. I think somebody ought to point out that it's only got 5 wheels, not 6. Somebody seems to have forgotten the wheel at the back there and replaced it with a shopping bag, but I'm sure that they realize that. And hopefully this will be complete and tested and ready to be sent up before too long. There's a cheer going up from the people that are building it there. So if I've piqued your interest in robots on Mars historically, what has happened in the past, what is happening now, and what is likely to happen in the near future, if you go to these national space agencies, you'll find all the information you could possibly want. Thank you all very much.